Hello again, kids. Please put this in your warm-up book. Make note of your homework is a couple of handouts, and I need you to know that for the test, these handouts here that we're going to do today, some in class and some for homework, are your only examples. Right? There's no book examples of these problems that are going to be on the test. Now they're going to be on the calculator portion of the test, right? So that's on Friday. So number one, find the exponential equation. So as soon as somebody says exponential equation, you write a times b to the x. Now remember, when we have a times b to the x exponential equations, when your x is 0, the y coordinate is 5, but remember that's also your a. So y equals 5 times b to the x. Now this is so this, remember, is my 0 point. This is my second point. So plug in 9 for y, 5 times, I don't know the base, to the 1.5. Divide both sides by 5. And then undo right, get b by itself by raising both sides to the reciprocal of the exponent, and then just go to your calculator and hit 9 divided by 5 to the 1 divided by 1.5. You get 1.47. So my equation then is y equals 5 times 1.747, excuse me, to the x. And that is the exponential equation that goes through these 2 points. Now if you were to actually put this into y1, and if you used 1.47, you probably wouldn't, if you typed in 1.5, trace 1.5, you probably wouldn't get exactly 9, because unless you stored all the decimal places in alpha b. But since I wasn't using this exponential equation to make predictions, I just rounded. Number 2, find the value of x if that x comma 18 is a point on the exponential curve from number 1. So they gave me a y, so you need to plug 18 in for the y. Divide the 5 off. Now, unlike number 1, when I was solving for the base, I'm not solving for the base this time. I'm solving for an exponent. So remember, who gets exponents down out of log land? Come on, pen. Trying to get you to change colors. Come on. Right? You want this x down in front, so you need to turn this into log base who. Logs are exponents. And then put the 18 over 5 here. Me, I change this to base 10 so I can use my calculator. I just don't use that if you want to use that base changer function, you absolutely can on your calculator. So I did log 18 divided by 5, and I'm going to divide that by log, and I'm going to use a bunch of the decimal places that I had.
Yeah, it's for tomorrow.
And I got 3.5. to 6. Okay. So I wanted to show you two equations where, two different problems where one time you were solving for a base, so we used to isolate the base. When the exponent was a number, I isolated the base by raising both sides to the reciprocal of the exponent. But when I was solving for the exponent, when x was the exponent, I used logs to get that down. Okay? All right, so you have a couple of handouts that the substitute had for you. So look at this one. So these are like, you'll have word problems like the book, but you will also have these kinds of word problems. They're science ones. So number 1 has a twist in it, in that the rate is kind of, or the base is kind of hidden in the words, and I'll show you what I mean. So firstly, the number of streptococcus, that's a great word, right, is a controlled colony is found to double every minute. We're looking for the 0 point. Initially, 300 bacteria present. So so that's 300 times I don't know what to the x. In about how many minutes will there be 1 million bacteria? Wait a second. They're asking me a question that they only gave me the 300. How am I supposed to solve for the base? Uh-oh, panic. Gasp. What do I do? Go back to the words and see if there's anything that's going to help you. Go back to the words of the problem. I know initially I have 300, but go back here. The bacteria is found to what? Double every minute. So that means at 1 minute there must be how many streptococcus? Okay. So there's your second point. So now plug 600 in here. That was Deanna, Delaney, whatever your name is. Divide by 300, and hey, what happens? Sorry, I forgot to put the 1 there, right? I had to put 1 in 600. 2 equals b to the 1. Hey, what do you suppose your base would be if your bacteria tripled every minute? Clever, huh? So my actual equation is y equals 300 times 2 to the x. When will there be 1 million bacteria? So they want me to put 1 million in for y. So 1 million divided by 300 is equal to 2 to the x. But that means that log base 2 of 1 million over 300 is x. And I just go to my calculator. And type. Again, I don't care what 10 to the 6 divided by 300 is, right? And I got 11.7 minutes. Right? Okay. Don't forget units. So the twist in that one was they only gave me my initial, my 0 point, and I had to look back to the words for my second point. It wasn't explicitly given like it was in the warm-up or in some of our book problems. Now, after I have the equation, how many bacteria will be present after 5 minutes? Okay. Or you could just write this, since you're plugging in for x. And I get 9,600 what? Good. Now the twist in number 2 is that I gave you the equation. You don't have to come up with it. If I gave you the equation, notice in number 1, I gave you the initial value and you wrote the 300. This time I gave you the equation and asked for the initial value. Right? So how many grams were there originally? Originally means at time 0, how many was there? Now you can plug in 0 for time, or you can recognize that that's always going to be your A value. How you justify your answer is you write the radioactive material at time 0 was 750. Find the amount of material remaining after 20 days. That's a time, right? So you're just doing R of T. Now this equation has E in it. Don't freak out. Just look at your calculator, type 750, and then do the second ln button, right? E to the negative 0.2 times 20. Oops, I should put R of 20. R of 20 was 13.7 grams. Now please put a star next to this. I'm going to do this problem just straight up first, and then I'm going to tell you how some of the science verbiage I need you to recognize in this. Find how many days have passed when 1/3 of the material is still radioactive. What does that mean? 1/3 of the material. Huh? What material? This material. How much was there originally? If there was 750 originally, what is 1/3 of that? Right? 1/3 of that would be 250. So it wants to know, the question is asking, of the 750, what time will it be? How many days will have passed when there's 1/3 of the original left, which is 250. So take this 250 and set it equal to Now check out what happens though when you do this, and this is a check for yourself. You can tell that you've done it right. Look what happens when you divide the 250 by 250 by 750, right? You have to divide both sides by 750. Guess what you get? That's right, 1/3. So I'm going to go over here. Right? Your exponent is up in exponential land. Bring it down with logs. So you have the log of E. Logs are exponents. And put the 1/3 there. And then divide by negative 0.2. So on my calculator, I hit ln 1/3, and then I divide by negative 0.2, and I got 5.5. 5.5 what? So notice a shortcut. I could have done a shortcut to this problem. As soon as I saw the 1/3, I could have jumped right to here. That will always happen. What do you think? How do you think that would be? Find how many days have passed when one half of the material is still radioactive. Now, if you don't want to do the shortcut, that's fine. You just go up here and you say 750 was the original. What's a half of 750, right? And then you would get 375, and you would put 375 into here. But guess what you get when you would divide both sides by 750? Right? So any question like this, when you're dealing with radioactive decay, if they ask you about 1/4 of the material left, 1/3 of the material left, 1/2 of the material left, you can just drop off the A, right? Notice A is gone, and put the fraction of what's remaining over here, 1/4, 1/3, 1/2. If you don't like that, you just go through this step, right? Take the original and cut it in half, or take the original and cut it in 1/3, and then you leave the A value there. The reason I want you to put a star by this is because sometimes, in particular, when they say 1/2 of the material, science people say this. They call that the half-life. So if you see a question that asks for half-life, what they mean is half of the original. Half of the original material. And where do you see the original? It's always your A value. Okay? So one of the handouts you have for tonight has you practice this science application. Oh, no, I think this might be the only one I gave you for science. All right, next we're moving to money. So finance applications. So let's talk about banks. Now you need to know banks know what they're doing. They've hired a lot of mathematicians, and they make the math work in their benefit, not yours. So let's suppose that Hannah puts $1,000 into a bank that pays 4% interest compounded annually. You don't need to write down all those words, but here's the words you do need to write down. You need to put down 1,000. That's her initial amount. 4% interest is her rate, and you need to turn that into a decimal. Compounded annually means the number of times she gets interest is 1. If she doesn't have put in any additional deposits, how much money will she have after 3 years? So here's how a bank does this. Now you can just watch. You don't have to take the rest of this. I'm gonna get back to this problem after a couple of screens, and you can just watch this. So I'm going to do the computation. There's Hannah's $1,000 times the interest rate of 0.04, and notice I'm multiplying by a number smaller than 1, right? That's 4%. So that's $40. So the initial amount was $1,000 plus 40 is $1,040. So after 1 year, she's made $40, right? For doing nothing. She just let the bank have that money. Now the bank was able to keep that money for an entire year and use it. They got more interest. They got more than $40. Now I'm going to do something crazy. I'm going to take this 40 here, and I'm going to do substitution. And usually we do substitution and make something simpler, but remember this is 40 right here. I'm going to take this 40 and I'm going to replace it, this 40, and replace it with this 40 here. See that? This is still 1,040, right? Now I want you to, good F word, I want you to factor 1,000 out of this expression. So put the 1,000 out front, and 1,000 divided by 1,000 is 1, and 1,000 divided out of this product is just the 0.04. And I'm going to leave that as 1 plus 0.04. That is equal to 1,040, right? Now I'm going to do the next year. So the next year, don't forget, you start with 1,040, and then I added 1,040 times 0.04. But I'm going to do something crazy. I'm going to take this 1,040 and replace it here and here. That's just algebra, right? This is 1,040 plus 1,040 times the interest. Now I'm going to go to the next screen and just make this bigger to factor out the 1,000. I'm sorry, I'm going to factor out the 1,000 times 1 plus 0.04, right? So let me just highlight that here. On the next screen. So I want you to factor. So we're going to pull 1,000 times 1 plus 04 out of the first term and the second term. Right, so what happened? Oops, I'm sorry. Factor out the 1,000, my bad. I made too big of a box. But gee, that means I have this twice. I could do this again, and I will get, after the third year, hey, an exponent of 3. Wait, what? How many years was this? An exponent of 2. So I could continue on with this pattern and show you that there are 2 ways to figure out the amount I have, right? The amount I have in the bank, or Hannah has in the bank, after time in years. One way is called recursive. A recursive formula, you don't need that. We're not going to use this, hint. Because the recursive formula means I always have to use what I had last year and then add the interest rate, which is smaller than 1, which is why I have to add the 1 to it, so that you're increasing, right? Or this is called explicit. And explicit because I don't have to know last year's amount. I just have to know how many years I'm talking about. This is the formula I want. So now let's use that formula and answer the question about Hannah. Oh yeah, don't forget, they talk about rates as a percent, but you have to use it as a decimal. So let's use our explicit formula for the amount Hannah has after 3 years. So after 3 years, the initial amount. So we've called that our 0 point before, or initial amount. In banking world, that's called the principal. You have to multiply that times 1 plus the rate, because again, remember, the rate is a number smaller than 1. So if you multiply your principal by a decimal smaller than 1, your principal goes down, and you want the amount to go, your amount of money to go up. And then time is the years that have passed since your initial deposit. So here's Hannah's situation. Here's her initial $1,000. Here's her 4% interest, compounded every year, and she left it in for 3 years. So remember, after 1 year, she made $1,040. After 3 years, she makes $1,100 something, right? So she's made, after 3 years, she's made $125 about. Now, I'm not, $125 free money is great. Still, after 3 years, though, that's not a whole lot of interest. How about 30 years? What if she left it? I mean, she must make a ton of money if she leaves it in there for 30 years, right? Not that much, right? Doesn't seem to be. It certainly didn't grow $40 every year, right? Now, Riley says, Hannah, you know what? You made a good decision with your money, and you found a bank that gave you 4% interest once a year. But me, I found a bank that pays 4% interest every quarter. So what's Riley's situation? We can't use Hannah's formula. We have to use a new formula. This is the formula that you want to copy down in your book. So if you haven't done any notes so far, you need to do this one. You need to memorize this formula. And I really did use this formula with Hannah. It's just that the n is introduced there, and n is the number of times the interest is compounded per year, and for Hannah, n was 1. The n is used twice, though, here. You have to take your rate and divide it by n, and then you also have to raise your exponent times n times t. So look at Riley. Riley had the same $1,000 that Hannah had, same interest rate, but it was divided by 4 because compounded quarterly. Notice that quarterly 4 shows up here and here. And 30 is how many years she left it in. So she must make us so much more money than Hannah, right? Now remember, let's go back. After 30 years, compounding interest 1 time a year, Hannah made $3,243. How about Riley? Geez, 4 times a year, she only made, right? It's not that much more. Well, Nick said, ladies, I found a bank that gives me interest every single day. Every day. Now, you can argue about what, in a year, how many days are there? 365, 364 and a quarter. I don't care. Right? Notice I chose daily to be what? 365. If you want to make 364, you want to make it 364.25. As long as you show me what you're plugging in there, I'm fine. Notice same $1,000 like Riley and Hannah, same 4% interest, but got that 4% interest every day for 30 years. Nick must make so much more money than Hannah and Riley. Oh, snap. Math, pretty cool, huh? I mean, for the bankers. This is why bankers pay a lot of money. Your money does grow, but it's bounded. It's never, you're going to keep adding smaller and smaller numbers over time, and that sum is never going to go above a certain number. Isn't that crazy? Don't forget that the n has to be used twice, right? A lot of kids remember the n either in the exponent or dividing the r, but sometimes Kids forget to use that n twice. Well, Kayla was like, y'all just don't know what you're doing. I found a bank that gives me money interest continuously every single second. You can't even count that fast. Continuously. Right? Cha-ching, 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 cha-ching. Every second, Kayla's getting interest. So she must make a gazillion dollars. The problem is, what do I put in for N? How many times am I getting interest? Infinity times. I can't, the thing is, infinity is not a number. You can't put infinity and divide 0.04 by infinity. You can't put infinity up here and multiply it times 30. Well, that's where calculus came to the rescue. And calculus got a formula that I can't tell you. I can't show you the math now, but in 2 years from now, you're going to remember, I'm going to say, remember Kayla, remember in AAF when I told you about interest, I told you about this formula. You in Algebra 2, you just have to memorize that if your interest is compounded continuously, you cannot use our regular formula. You have to use PERT. So I don't know if any of you are old enough to remember PERT, or if they even sell it, PERT shampoo, right? Notice that N is gone. There's no N because N is infinity. N is in this equation, it's just hidden, and it's calculus that got it for us. But you need to know that if you are getting interest continuously, you can't use the first formula, you must use PERT. So how much money does Kayla get? With the same $1,000 to start with, the same 30 years, the same interest rate, but look at the base. Naturally, E came out of the calculus when I was dealing with infinity. Remember, that's a bit, I mean, it's just 2.7-ish, right? 2.7, Andrew Jackson, window wiper, dot, 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 dot. She's going to make an infinite amount of money, right? Oh, snap. Those mathematicians, those bankers, they know what they're doing, right? Nick got money every day and got 3,319-ish, right? She got 3,320, getting interest faster than every second. Whoa. Craziness. Now, do be careful when you will have a calculator to do this. Please make sure the rounding rules that you use money. I don't care if you round up or round down here. Let me tell you that the banks always round down. But don't give me 3 decimal places, right? It's money. Give me 2. Do be careful with your calculator, especially if you have the older software, right? The older software that uses this multiplication symbol and has this caret here. So do just be careful with your parentheses. And then you must memorize both of these formulas, right? This formula is the one we used for Hannah when N was 1, for Riley when N was 4, for Nick when N was 365. What number would you use for a bank that compounded interest monthly? Right? N would be 12, right? Here, though, this is what we used for Kayla. When N, this was compounded continuously, where N approached infinity. Interest was compounded continuously. Right? This was compounded yearly. quarterly, daily. Okay, and of course I could say monthly, I could say bi-monthly, I could say 3 times a year, you know, whatever. All right, so you have a couple of book problems, and then you've got the couple of handouts. I think I have a science one and a money one for you to do. All right, so again, these problems will all be on the calculator portion that will be on Friday. So you want to study, then for Thursday you want to study all the non-calculator stuff, right? Which includes all the exponents and logs and solving log equations, the ones that don't require a calculator, solving exponential equations that don't require a calculator, which means you can change to the same base, all of that stuff, and then graphing and transforming, that's all going to be without a calculator on the first part. So Thursdays is a much longer test. Okay?
Okay, now.
All right. Have a good one.
A what? It might.